Let's look at the problem number 43 from test 2. This is from theory of machines. The topic is theory of machines. So what is given is a 4-bar mechanism is given as shown in the current location, where A and C are hinge joints and each of the links are connected by hinge. Okay, and velocity of B is given. This is C actually. This is T. Okay, so the velocity of B is given and the velocity of C is asked in this current position. The lengths are given. AB is 30 centimeter, CD is 45 centimeter, and in this position AB and CD are perpendicular to the link AD, which is nothing but the ground. Okay, so we can see that as CD, the link AB and CD are in fixed axis rotation about A and D. Fixed axis rotation, that means their ends A and D are fixed as shown. Rotation about A and D respectively. So let's take D, this is C, this is in fixed axis rotation, so C, the velocity of C has to be horizontal. Okay, so let's draw link BC, where B also will have the horizontal velocity V, and VC is something which is asked. So now this link BC will be in plane motion, and any body in plane motion, if you take two velocity vectors, like for example if you take two velocity vectors, a general body, and if you draw the perpendicular lines, so you will get the instantaneous center. And instantaneous center is basically the center about which the body appears to be rotating at that instant, at that moment of time. So for this, if I draw the perpendiculars to the velocity at B and the perpendiculars to velocity at C, it will meet somewhere at infinity. So this happens only for a body in a pure translation. Like if you have a block sliding on a surface and you take any two points on that translation body, the velocity vectors are like this, and the perpendiculars meet only at infinity. So this happens only for a body in pure translation. So this is a special case when the 4-bar mechanism takes this position. This link BC, which otherwise have to be in plane motion, is now in pure translation motion only for this special case when the links are at 90 with the ground. So as you can see, if you compare this with this, the velocity of C is basically the velocity of B, which is B. So we have solved this by instantaneous center method, and the instantaneous center for this is at infinity. So the answer is A.